I was too scared to run a live demo, so I prepared slides. So you can look at them later on because they're all on the Indico. The team of people, Patrick already mentioned the bulk of the work has been doing switching from this crude prototype that I came up with to the system you see nowadays. Valentin was a postdoc, or is still until the end of the year postdoc in our group, funded by the AHEAD European project, and Attila is in the back of the room somewhere, a PhD student who joined us last year. So let's quickly run through the main features. I mean, I assume you've all seen that, but I just want to also to highlight new features that we came up with this version 2 that you see now on the web, and maybe a few features that you're not so much aware of. Again, the website is here. Patrick already mentioned the core layout of the web front end. There you see an overview of the latest transients happening in a list view, and then on the sky. You can click on each of the events if you're interested what this is, or you can just scroll through that list and select them here. We moved between version 1 and version 2. We combined the legend, so the color scale and the marker style, and the filtering. So now you see these buttons here. So if you want to select one of these and you're not interested by Fermi, for example, GRBs, you just click on that and they disappear. If there are too many supernovae around, then you just click on that button and they go away. So that's going into that step that we just discussed, that filtering will become more and more important, and we try to facilitate that as much as possible. The other thing, the new thing, so this sky map down here, you can make cone searches and things like that. So it provides you with a view of spatial correlation, but you lose the time correlation between transients. So we introduced this timeline where you see, if you then filter and cone search and things like that, you see the time difference between events in an easy to understand way. You can use the end buttons there to define this time range, which by default is 2 weeks, which gives a nice but not too full sky map. You can move this timeline. There are arrows between, so you can move the timeline back and forth. If you only want to switch to 1 or 2 days, you can click on 2 of these grayish bars, so you can select the start and the stop of your time window and things like that. So you can play with this timeline, and if you messed it up, you can always get back to the original version easily. So that's for temporal correlation. It's quite easy and nice to have. We mentioned the very important links to external platforms, because I mean the community has been building up a huge set of information and platforms. So these are now in the scrollable list, so you can move through them. If it annoys you that this list moves automatically, you can just switch it off there. And I don't go through this list of external services. Just the main idea is there that you don't provide like a bookmark list, but we always point to the exact location in the sky or the exact event, so that you don't have to recopy the same coordinates again or the same time range and things like that. So you, if you have something that is missing, please bear that in mind, that we don't just point to an entry to some other platform that you can do in a bookmark in a generic way. Then the main thing, and that's been increasing over the years, is this information box where you see the raw information from the event. So you can get, for example, if it's a VU event, you can get direct access to the VU event again over 4PySky. You get the name, you get the localization in degrees or hour, minutes, seconds. You get the uncertainty. You get then the associated parameters, for example, for this ice cube neutrino, there's a false alarm rate, there's an energy, there's an astrophysical probability, things that might be interesting for the user to take a decision that this is indeed an interesting event. Then there's a text by default, generic text that has been template based and filled with the information on each event, which is mainly there for the amateur astronomy community to tell them what is a neutrino, how do we detect neutrinos, what do these values mean, for example, the false alarm rate and things like that. For this audience, you can switch to this science mode, so the same information is displayed, but the text goes away and is replaced by the visibility plot, which is probably much more useful to you. So you see in that region, so let me just zoom in and highlight a few of these new features for the visibility plot. So now you can select the date because it's from time to time it's interesting to recall why we didn't observe this and this transient with this and this observatory. So you can recreate the conditions from 2 years ago and see, yeah, of course, because the transient was happening during daytime and the IACTs are limited to dark time. Or if you want to create a plot like that for a talk or things like that to highlight why you did observe during this period and things like that, it's quite useful. The other thing is, if you then decide to observe, you get links to weather forecasts at the site of the observatory. So you have selected an observatory and then you want to see what the weather forecast for the coming night is. If it's raining all night, maybe it's not urgent to wake up your shifters. So you get these two weather forecasts. There's even a third one if you have selected an observatory which provides a publicly accessible weather information like a sky monitor or all sky camera, things like that. You get a direct link there. And you can also get the sky view, so you see a real-time view of the sky above your observatory, including all the nice Starlight satellites and the Starlink satellites and all the stuff flying around. So you get a feel of what the sky above your selected observatory looks like. Last but not least, there's a new button over there, search for ATELs. So if you have selected a source and you want to check if there's archival data or if there are ATELs on that source in the past, you click there. And if there are a long list of links directly to the ATELs associated to the source pops up, and that's quite useful to see. Okay, my AGN is flaring, but it was flaring even stronger 2 years ago, and things like that. The selection of the observatory hasn't changed much, so you can customize where in the world you want to observe. So we have a list of predefined observatories. You just go there and select one. If you don't find it, you can search for it either with the IAU code or the name, and then store it. So save observatory, and then it pops up over there to get a list of observatories you can reuse it, so you don't have to search for it again. And if that doesn't work, you can define it by hand, and it's just giving the coordinates and the altitude and the name, and then you can. That's mainly useful for again amateur astronomers which have their small telescope in their backyard and want to save that for follow-up observations. Then I mentioned this view of the latest transients, but of course you want to zoom into that region surrounding one of these. That's what we call a cone search. You can either the selected event is always given here now, so you can click on cone search directly, or you can use this previously existing button between the latest transient and the cone search to do so. And then the view changes, so you get a small animation zooming into that region, and we have seen that a region around that recent neutrino quite often today already. So no need to highlight that further. So you can select the event either in that list or again on the sky map. And then, of course, I mentioned this search for ATELs. So if you select TXS or 546 and then you search for ATELs, of course, you get the long list of all the ATELs associated to the 2017 event. Just mention that list goes beyond the screen, so you can move it with your mouse back and forth if you didn't realize it yet, because it might not be totally obvious. That's that. The other thing is these cone searches are typically triggered around transients in our list, but you can also do that manually. So there's this field that is now more prominent than in the past, because not many people knew about that. So you can either change the coordinates where you want to search for Fermi sources or catalog sources, or transient within the predefined timeline that you have above. You can do that by changing the coordinates. If you remove the last degree sign there, then you get a pop-up asking if you want to use degrees or hour, minute, second, so you can use both. A really helpful thing, at least for me, is you can also search for source names. So you can delete the predefined source name and put in your own. And this has an auto-completion feature based on the list of all our catalog and transient sources. So it should be up to date. And it really helps you if you, like myself, don't remember all these phone numbers of these sources. Then the coordinates are filled automatically. You can select the radius of your cone search up to 10 degrees, and then you hit the search button over there. If your source that you input, and you're quite certain that you input the right name, but it's not found in our auto-completion list, you can still click on that information button there, and then you query Simbat and see if the source is found, and if so, all that field will be filled automatically. But there's a few features, I guess, not many people use, and it's quite useful to see. Even if you just want to look up coordinates of a source or things like that, you can use that directly. I have to speed up. So personalization. So you can create an account if you want. It's certainly not necessary. There are a few advantages if you do. So if you log in, all your settings will be synchronized between your web view and your smartphone, for example. So the observatory selection, including your manual observatories that you just defined, the event filters. So if you're not interested on seeing supernovae on the website, you're probably also not interested in seeing them on your phone. So that gets all synchronized via these accounts. And it also allows us to have admin access and also private information of certain observatories that don't want to have their information in the open. The other button over there that I didn't mention yet is the information button, which brings us to astro-colibri.science, which is the bulk website with information, where you find, as we mentioned earlier on, the information about the public accessible API endpoints over there, a few members of the team, documentation, which has the change log of the different versions, for example, a link to our YouTube channel with a few explanatory videos, very nice merchandise store, and last but not least, our very own Gamma Catcher game, which you should all download on your smartphone just to make my kids happy. And again, the same thing, exactly the same features are available on your smartphone, and I guess you realized all of that, so you get the same buttons and the same features, plus these real-time notifications that you can switch on and off. And I stop here. So Patrick already mentioned that we had this first version released in August. Currently we have more than 2,000 downloads. On average, we see like 30 daily users. There's short-term goals. So there's one feature. So I mentioned that the app is exactly the same as the web. which is a bit of a lie, because there's one feature is this manual cone searches where you input your coordinates or your source name. That is still missing in the app, but it's coming up very, very soon. And then, of course, I mentioned that the underlying cloud computing is touching its limits, so we are certainly looking into moving that somewhere else and improving it. And last but not least, that's the most important thing. I mean, we are here to get your ideas and your feedback during the whole week and afterwards. So please be creative and come up with new features. Thanks.